Hello students, right here again. Today we get to look at notes for section 14.3, factors affecting solvation. Our objectives: you're going to need to describe how intermolecular forces affect solvation, define solubility, and understand what factors affect solubility. Review vocab: exothermic, chemical reaction in which more energy is released than is required to break the bonds in the initial reactants. Quite a bit of new vocab will come along to in this section: solvation, heated solution, unsaturated, saturated solution, supersaturated solution, and Henry laws. And our main idea: factors such as temperature, pressure, and polarity affect the formation of solutions. So our definition for solvation: process of surrounding solute particles with solvent particles to form a solution. If we do have solvation in water, we call that hydration. And the attraction between dipoles of a water molecule and the ions of a crystal are greater than the attraction among the ions of a crystal. And a little illustration of sodium chloride, salt dissolving in water. And what happens is the water molecules are attracted to a chloride ion with the positive end of the water molecules next to the negative end of the negative chloride ion. And then we also have the opposite thing going on here with the negative end of the water molecule attracting to the positive sodium ion. As mentioned in that last point, these attractions are greater than these attractions, so it dissolves. If those attractions were less, it wouldn't dissolve. Sucrose, table sugar, has some OH bonds, which become sites for hydrogen bonds in water molecules. So the OH on sucrose can attract to the H2O. So sugar dissolves in water, not to the extent that salt does, but it does dissolve. Oil does not make a solution or dissolve in water because we have little attraction between the polar water molecules and non-polar oil molecules. So during solvation, the solute must separate into particles and move apart, requiring energy. And this overall energy change that occurs during the solution formation is called heat of solution. Things that will affect solvation, if we stir or shake, will speed up the rate of solvation because it causes the dissolved particles to move away more quickly and allows collisions to occur. Anything that will increase the collisions is going to increase the rate of solvation. So, breaking apart the solute into smaller pieces, increasing the surface area, allows more collisions, increases the rate of solvation. Temperature increases, rate of solvation increases, because as temperature increases, the particles are going to move faster. They're moving faster, more collisions. So it's all based on number of collisions. Solubility, determine the nature of the solute and the solvent. Unsaturated solutions simply contains less dissolved solute for a given temperature and pressure than a saturated solution. A saturated solution contains the maximum amount of dissolved solute for a given amount of solute at a specific temperature and pressure. Solubility is affected by increasing the temperature of the solvent because the kinetic energy of the particles increases. Yeah, the little chart we will be using, charts like this, and it just shows at various temperatures how much it dissolves. Like calcium chloride here, as the temperature goes up, solubility increases a lot. Sodium chloride, temperature doesn't affect it near as much. And get some which are a little unusual, where the solubility actually goes down as it heats up. Most of the time to go up. Supersaturated solution, or the unique situation, we'll look at an example of this in class. Contains more dissolved solute than a saturated solution at the same temperature. To form this supersaturated solution, a saturated solution is formed at high temperature and then cooled slowly. Very unstable situations. We'll see an example of this in class. And another chart of solubilities, in chart form rather than graph form. Let's list out some different elements, their formulas, and at some specific temperatures, how much will dissolve in 100 grams of water. Gases tend to be less soluble in liquid solvents at high temperatures. So if you got gas heated up, gas is going to come out of solution. If we increase the pressure, solubility of gases increase. And Henry's law relates some of this. Solubility of gas directly proportional to pressure, and we get this little formula. We'll be doing some work with that in class. A few quick review questions. The least amount of solute unsaturated. Saturated contains just the maximum amount. Supersaturated contains, oddly enough, more than the maximum amount. At a given temperature, solubility of gas is directly proportional to what? That's the pressure. We just seen that a little bit ago on Henry's law. So that completes our notes for section 14.3. In class, we'll expand on some of these concepts as we look at some questions. That's all for now.